Welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without classroom. So learn physics at your convenience. Let us start our today's lesson, that is capacitor. Students, it is a device that we use for storing electric energy in the form of charge on its plates. So we can say that capacitor is a device that is used to store electric charge. Now let us see what is the construction of a capacitor. Look at this diagram. A simple capacitor consists of two metallic parallel plates separated by a small distance between them. The medium between two plates is called dielectric. It is either air or any other insulating material. Remember that the space between two parallel plates of a capacitor should be an insulator, either air or any other insulating material. So it is the construction of simple capacitor. In market, you may have seen a device like this. It is a practical form of a capacitor. There are so many other types of capacitor that we see in the market, but one is this device that is called capacitor. Now students, let us see how a capacitor works. When the plates of the capacitor are joined with a voltage source or battery, then the charge flows from battery to the plates of capacitor. Since there is dielectric, means insulating material, charge cannot pass through it. As a result, the charge from the battery starts to accumulate on the plates. On one plate, if there is charge plus Q, then due to electrostatic induction on the second plate, the same amount of negative charge deposits. Or in other words, we can say that charge from the positive plate moves and accumulates on the one plate of capacitor as plus Q. Similarly, negative charge from battery when travels and accumulates on the other plate of the capacitor. When we say there is charge Q on the capacitor, we mean that one plate has plus Q and other plate has minus Q charge. Now, the opposite charges on the two plates of capacitor produce the potential difference between the plates of the capacitor. This potential difference V is directly proportional to the charge. So we can write Q is proportional to V. More the charge on the plates, more will be the voltage or potential difference across the plates. Removing sign of proportionality with sign of equality, we multiply the right hand side with some constant. So we can write Q is equals to CV, where C is constant, and in this case it is called capacitance of the capacitor. Students, it shows the ability of a capacitor of storing charge. How much charge a capacitor can store. So we call it capacitance. C is the capacitance of capacitor. Now rearrange this equation. What is capacitance? It is the ratio of charge to the potential difference across the plates of capacitor. Charge on the plates of capacitor, ratio voltage across the plates of capacitor. So what will be the unit of capacitance? That will be coulomb per volt. Coulomb is the unit of charge, volt is the unit of potential difference. So unit of capacitance is coulomb per volt, and we call it farad. So unit of capacitance is farad. 1 farad is the capacitance if 1 coulomb charge on the plates of a capacitor produces a 1 volt potential difference across its plates. Students, farad is a big unit. Usually we use the smaller units of capacitance. They are microfarad and picofarad. 1 microfarad is equals to 10 raised to the power minus 6 farads, and 1 picofarad is 10 raised to the power minus 12 farad. Students, this is all about the capacitor. That is a device which we use for storing electrical charge. What is its construction, how it is connected for storing the charge, and what is its unit of ability of storing the charge. This is all about capacitor. I hope it is clear. Students, thank you for sparing your time to watch this video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.